All right. So we're gonna explain the ICP 5. So first we have the Titanic dataset. And to answer question 1, yes, females have a significantly higher survival rate as shown below. We used sex or gender as our feature, as well as class um, as sex. And then we showed the class correlation with survival rate. And then we also replaced all of the non-values with means. And then we also showed the sex survival rate. And then we replaced the categorical data with numerical. Yep. And then we combined it, and then we trained and split the models. And then we used the SVM to train our model, and we showed the accuracy, which was 65.72. And then we showed the SVM confusion matrix right there. And then we also used the Gaussian naive Bayes algorithm. We got 77.99, show the confusion matrix. We also used the multinomial naive Bayes, that was 60.09, showed that confusion matrix. And the Bernoulli's naive Bayes algorithm, which was 80.72, and then showed the confusion matrix for that. And then finally, we had the KNN algorithm, and we also showed the confusion matrix for that.
Okay, the next step of the project was to recognize handwritten digits. So we loaded our data in. The data set is native to the scikit-learn library. Kind of explored the data, explored that file that we imported in, got the shape of the data. So we knew exactly how many attributes we had, or how many rows we had. Here we visualized one of the images along with its label, and then down here we visualized quite a bit of the images, so we can see that they're pretty grainy. We then divided the data into buckets, so we can see they have around the same number of rows in each bucket. So this is a good data set to learn on. There's no overwhelming bucket that may introduce a bias to the data. We split the data, ran it through a support vector machine, and we trained it with the testing data, predicted with the testing data, and with this we got an accuracy of 99%. And then we visualized that with a confusion matrix down here and a classification report. Similarly, we did a k nearest neighbors classifier, and we did a for loop to decide what the best number of neighbors was. And here we just used 6 neighbors because we had a 99% accuracy. And again, we did a confusion matrix for that and a classification report. And finally, we just did the Gaussian nearest neighbors. This was had the worst accuracy with 84%. And again, we can kind of explore those results. We see that it mistook a majority of the mistakes were made. It predicted the label 8, but it was actually the label 2. And here we're just picking a random image from the test set. So we're choosing the 50th index, and all of the models got this prediction right. We can just use .predict to predict that image, and the actual label is 4. So all these classifiers worked. And then finally, we use the UCI version of the data set, and This was pretty similar to the second part of the exercise, except for the data set was in a poor format, so we had to come in and do some pre-processing. So we imported the training file and the testing file. We stripped the lines and split the lines, appended them to a list. Then we made all of the list integer types because they were previously a string. And then we simply just sliced the lists to get the data how it was for the original set. And then we can view the shapes. So these shapes are similar to what we had before. And now we can train on these data sets. So the support vector machine gave 98% accuracy, similar code as from before, and similar classification report and fusion matrix. Then we did another for loop to determine the best number of neighbors, and I believe we used 5 here, 99%. Again, confusion matrix. And then we finally did a naive bias classifier, accuracy of 84%. And then again, it had a hard time. It predicted a lot of 8s when there were 2s. So that was a quirk of that particular classifier. And that's all.